Hey everybody in YouTube land. Now comes the time to start working on the IntelliStar. So if you remember in the previous video, I did a brief hardware overview on this machine and just kind of did a general overview on how this thing works from a hardware standpoint. But now it's time to start restoring this thing. So I have, if you remember from previously, I have some capacitors that have to be replaced. So we're going to go ahead and pull this board out of here and get that done. Another thing too is there's some things that have transpired since I've done the last video. For example, remember it was missing the cage that went here, and those are the parts that were in it. Well, I ended up securing another IntelliStar machine that I ended up parting out and used some of the parts for other people to get some things done. But yeah, I was able to get that done, and now I can finally start piecing some stuff together. So I'm going to go ahead and pull this board out and start working on it. But in order to pull the board out of these, you have to remove the power supply, and you also have to remove the retaining cage, because there are screws and things underneath you got to be able to get to. And the way that's done is you just lower the front panel down or remove it, and the screw, this comes out. You just pull these two tabs in like this, and then this gets pulled out, which I don't know if I can do single-handedly because it's really in there. So you pull that out, and then it will reveal, you get these two screws here, these two screws here, and then after we pull that out, then it reveals screws down here, one there and one there. And once you take those out, well actually there's two more screws there too, but once you take that out, this cage should lift up like this, and you'll be able to access the ATX connector and all that fun stuff. So another fault that these have too is not just the power supply, but these things run 24/7, and these power supplies, excuse me, the motherboard, the power supplies get warm, and the capacitors inside the power supply starts drying up. And then what happens to these is, if these are ever turned off in the head end and they're shut down and they go to bring them back online, they won't turn on. If they cool off, they just will not power on. And the reason why that is, caps go bad in these. And on top of that, the capacitors in here cause a problem too and won't allow the ACPI manager to come online. So there's a couple things that go on, but this is another problem. So what we're going to do in this video is we're going to restore the motherboard, but we're also going to restore the power supply. Actually, I take that back. So you don't have to take these two screws out, but you do have to take the ones out in the middle and the four that are in the front here. So we can just lift this guy out of the way, and it will expose everything we need to get to work on this thing. So what I need to do now is carefully hold this out of the way while pulling this out, which I'm going to have to pause the camera. Alright, so now that that is out of the way, we can start safely unplugging things from the motherboard. We can start removing the RAM and taking all the screws out, fans, all that stuff. That way we can get this board out and work on it just like any other computer. That noise in the background you're hearing is this machine running, so don't mind that. But we're going to go ahead and start unplugging some things. So I can typically figure out where all of these go. It's pretty standard with Intel motherboards. So I'm just going to move these guys out of the way and try to keep them clustered together, because they're going to want to rest in their natural position, which will make it easier to plug that stuff in. Next thing we're going to do is unplug the IDE cable, get it out of the way, make sure all my wires are clear from here, remove the fan connector there, move that out of the way, get this out of the way, unplug that fan connector, so it's got to come. Actually, you know what? That doesn't need to come off. I don't need to remove the heatsink, although I think I will, so I can repaste it, because the paste might be a bit dry after 100 years, so. But now that I'm getting all this stuff out of the way, the actual board is now visible, so you can really get extent of the damage. Like there's a capacitor there that's gone, there's one there that's actually still good, there's that one's gone, there's a bunch of them back here that are gone. So you can really get a scope of the damage. Alright, so the next thing we need to do is actually get the board out. Alright, now the motherboard has been completely removed. It's easier just to slide it up, move things out of the way, and just pull it out that way. So now it's out of the way. This is loose, but it's still zip tied in, so I don't want to make things worse. I can just kind of set it out of the way for right now. This runs over top of the motherboard and it will get caught if you're not careful. And we're good. Everything's been removed out of this thing. Now we have the motherboard out. It's going to be a lot easier to work on and inspect damage. But not only that, there's another thing that has to be dealt with too. And the Thunderstorm card, the one I did a video on a while back, I had to borrow the firmware chip off of it, which is still in here, but I had to pull it so I could read it. And I have a, solder stuff to put all that back on because I had to help a friend out. He ran into an issue with his Thunderstorm card, so I just went ahead and sacrificed mine so I could fix his. So now I got to fix this one before I can do anything at this point. I got all the capacitors in these bags here. I think I have an extra set of power supply capacitors, but I do not recall. But only one of them has the motherboard caps that I need, so we're going to go ahead and get to recapping this board. I'm not going to video that because that's just a long process and it'll destroy my battery. So I'm just going to go ahead and mark off and start replacing all of these capacitors. I have the soldering equipment over here. This is the desoldering iron that I use, a Heiko FR301, and it'll allow me to, power through the ground plane and get all that stuff off fairly easily. And then I can solder the new ones on and we'll just get that done. But for safekeeping, I'm going to go ahead and remove this RAM so it's not, at risk of getting damaged. It appears that this is the original RAM because there's the weather channel part number. So, alright, we're going to go ahead and get this thing recapped. And we'll pick this video up after we get this thing recapped. And then we're going to test everything. Alright, so now we have all the new capacitors in there. There's all the old ones. They were rough. I mean, see the tops are domed on these guys. See if I can get it in frame. Yeah, they're done. So, junk. They all had to go. All the new ones are in there. I like to use these Worth brands because they're kind of pretty looking. But that's another reason I can tell it's been recapped. So, all this is done. I just got to get a new CMOS battery in there that I can get this thing hooked up, and I want to test it on the bench first before I go put it back in the case just to make everything work. Plus, I have a friend of mine's Thunderstorm card, an analog card, that I need to test as well. It got hit by lightning, so I'm going to try to fix that and test it in this board to make sure everything is good before we wrap this up. So, however, the next thing we need to address is this here. I've noticed that this is a common problem on Pentium 4 boards, so I think what I'm going to do is I have an old Core 2 Duo board that's just junk. I might steal the ATX Molex connector off of it and put it in here and at least get that fixed. But then I got to go look at the power supply and check the pins, potentially tighten them up a bit with my pick tool, and that way it gets a better connection. We'll see. We'll have to play that one out by ear. But yeah, that's a problem. That's only going to get worse. That's never going to get better. So I have to fix that. So here's the board that I want to steal the connector from. This is a 24 pin instead of a 20 pin. So I'm going to have to lop off the end of it, and it's not going to be perfect, but it's hidden anyway, so I don't care. This board is dead. Has been for a long time. I don't know what chipset is on here. I think this is one of the ones during the bump gate era, but I'm not sure. But what I do know is this board's bad, so I'm going to probably just steal the connector off of that one. Right. This is why I love this tool. Makes quick work of that. It's now out of there. So I don't see any damage on the top side of the board, but these pins, they're pretty, yeah, they're done. I mean, she got hot. So yeah, that can't be trusted. That's gone. Alright, well, now it's time to pull the other one off the other board, which is hiding over here. So getting this one out was much more difficult because this board is cheap garbage. I mean, pads were coming off left and right. I'd barely touch these with the tool and they'd just come right off. this is the this is where things have gone to, folks. I mean, just to get that off was a royal pain. Well, that was a royal pain in the ass because I finally got that off. Getting this off was an issue, and I had to trim off the last 4. And this is like a thermoplastic. It's very, very flexible. And it was extremely difficult to get that off without breaking out the Dremel. So, yeah. Well, it'll work. It's not the prettiest thing in the world, and it's not like it's a customer's machine. It's my own, so I don't really care. This board is for parts anyways. It's an old BioStar G41 crapper. So, yeah. Parts unit, and that will now be the new replacement. This has to classify as one of the ugliest repairs I think I've ever done, so I had to make sure I get it in the right way because there's a locating pin here, which is there. This one doesn't have that, but you had to trim and trim and trim, and it's yeah. But you know what? I'm not really going over form. I'm going over function. I don't really care what it looks like. It's going to be on the inside. Doesn't matter. As long as it works, we're good. Alrighty then, so we're all fired up. Plugged the power in, motherboard came straight on, and we're actually in the BIOS screen. So we're doing pretty good over here. The machine came right up, no problems. So we know we have the motherboard fixed. This is someone else's Thunderstorm card. I'm actually testing it for them, but we'll get back to that in a minute. So yeah, we're good. We got the board working up. I'm gonna fire it all the way up and make sure that everything looks good from my end. Alright, so we're all fired up into the IntelliStar software. This is the video signal coming from my Android TV box that's back here. It comes into the analog card here, and then the output from the analog card, which is composite, comes back around and goes into this monitor. So as you can tell, we have a picture, so that means the video input chip is operating and getting into the Thunderstorm board, because if it wasn't, we wouldn't have that picture. Now, however, with that said, if we go into the audio video input, there's no signal. We've got nothing. So I'm piddling around with it. Yeah, we don't have any activity at all. So that card, this card is bad. So what we're going to do is I'm going to grab my card. We're going to shut this thing down. We're going to grab my card, and then we're going to see if my card works with this thing, just to rule out that this card is bad. Now, I'm mixing two things here because this is just a repair video for these machines. So I'm mixing in a variety. So the motherboard was from my machine. We know it needed to be recapped from the previous video. These boards belong to someone else's machine that I'm working on for them. So I'm mixing in the broken things into one video. So I got the board working on my computer here. Then I'm testing his card, and we already have a carrier detect, all of that stuff is working on the input side. So the front end is fully functional according to this machine. So what we're going to do is we are going to shut it down. I mean, the clock is wrong. You're going to have that. So we're going to shut this thing down, and we're going to, a quick and easy way to do that is pull the power cord, shut it down. So we're going to put in a different card, and we're going to make sure that the problem is on this card. Alrighty then. So I got the old board out, which is laying over here. I grabbed mine, which is right here. This goes to this actual computer. I'm going to go ahead and put her in. Carefully line these ribbon cables up, because if you don't, you're asking for trouble. Because I've already had to unbend a pin on this card once. Alright, so let's get this thing fired up. Alright. While we're doing that, let's plug all this stuff in. Alright, we're starting up here. So hopefully, let's see. I'm trying to remember what each one of these were, because honestly I don't know. And you could tell how this one was used because this LED is dim, so this one was on the most. Okay. Alright, let me deal with this insanity. Alright, let's try again. It actually helps to have the SATA cable plugged in all the way. You know, just saying. There we go. Now we're starting up. Oh, the thunderstorm card just got initialized. See nice red LEDs. So what we're going to do now is wait for this thing to fire up and hope like hell that we get analog video out. As long as I have the BNC cable plugged in the right spot. You know, just saying. Oh man, alright. This is taking a while. It's probably scanning the file system. So let's see, syslog, daemons, blah blah blah, come on. I mean, it's a Pentium 4. It's not exactly fast. Oh, there we go. Now we're getting ready to go into X Windows. Alright, let's see. Got a click. Alright, got a video signal coming through. Both lights are on. Let's see. Will this work or do I have it plugged in wrong? Bingo! Bingo was his name-o. The analog board is bad. Alright, well mine's good, obviously. So, what we have here most likely is this chip here is defective. So we're going to have to replace that chip. Which means I'm going to have to order one. But, you know, before I get carried away, I want to check this filter network because this goes out to the BNC jack. So I want to check that filter network and make sure everything is kosher. Because if any of these components are open, it's not going to work. We're not going to get any video. So, my card works fine. So we can safely roll that out. Motherboard's working fine because if it didn't, we wouldn't have that. So now what we're going to do is we're going to verify output from the rendering engine. So we're going to load the presentation, and then what we're going to do is we are going to run the presentation. Alright, get that in there, AV, boom. Perfect. We have full output coming from the Thunderstorm card. I mean, that verifies the Thunderstorm card is working properly with my analog board. So the Thunderstorm card did not get damaged. So it's only this board here. And most likely is this chip. So, well, at least we know what we got to do to fix that. But until we get to that point, we can actually move on and start looking at repairing the power supply. So hopefully we can get the power supply up and functional for the original unit and start getting that thing put back together. So the next thing we need to do is to determine what failed on this card. Now, there is a relay here, and that relay is a bypass relay. So when this thing is not initialized, it just loops the data through so you don't lose anything that's on air. So it's not like we can read back to this BNC jack, but what we can do is we can look at the networks here and see exactly if there's anything that's blown apart. Not that I can tell. So let's check the inductor and see if it's open, which is going to be fun trying to do this single-handedly. So, nope, that one's not open. Alright, so let's check. Oh, hang on. This is considered ground. So what we're going to do is we are going to check from here to ground. 0.059. Alright, let's figure out what that is in resistance here. I know you can't see it, but 64 ohms. That seems a little on the low side. Okay, well, let's figure out what mine is. So let me unplug that one. Let me plug that one. Let's do the same thing. Let's figure out what mine is here. 76 ohms. Alright, that's interesting. So that's exactly what it's supposed to be. 75.8 ohms. On the other side of the inductor is 76.7. Makes sense. Alright, so let's take a look at this. We have on this side of the inductor 65 ohms. Okay, what's on this side? 64.2. I'm going to say this IC is damaged. So, yep, we need a new IC. It is an SAA 7120. That's what that says, I think. No, 7129. SAA 7121. So I'm going to have to order a new IC. It is definitely defective. Definitely a problem. So that's going to be it for this card for now. So in the meantime, we can actually move on and work on something else like the power supply. Alright, so we know this machine is good now, at least the motherboard is, so we can go ahead and start taking it apart and getting it put back into the original case and getting it out of the way. And then I want to start working on the analog board and all that stuff, power supply and all of that, but we'll get to that in a minute. But for now, we're going to go ahead and get this all unhooked and off the table and out of the way because we know that it works properly, and we're going to get back in the case. Alright, so I have the analog card out of the machine that we need to work on. So from earlier in the video, we saw that there was some issues with this chip right here. So what we're going to go ahead and do is, now that I got the camera positioned a certain way, and the problem is the camera, there's only so much room in my workspace, so I don't have a real good way to position the camera, so we're just going to have to do it this way. Hopefully you can read the meter. But like I said, this is the output, the composite output that would go out to the modulator. In this case, we weren't using a modulator, we were using a monitor, but this relay is just a bypass relay. It allows the input signal from the satellite to come in and loop right back out. Otherwise, when the machine is activated and the software is running, this gets digitized through these two chips, and it clocks out to the digital board, and then it shows up on screen. So the fact that we were getting my Android TV box on screen and with a clean signal means that these two chips are functioning, and only these two were hooked up at the time of the thunderstorm that happened. So we know for a fact that all these other ones are good, and I can roll everything else out. We know that this one's. So with these jacks, they're usually terminated at 75 ohms. So if I measure to ground and I put my meter between here and here, if I can get it in the pen. Yeah, I can't get it in the pen. Oh, that's right. Relay is disconnected, so of course it's not going to read it. 75 ohms. 75 ohms. Alright. This relay is in the way. So this is ground. All these are ground. They're all connected together. So what we're going to do is this circuit trace here runs up from the relay through this filter network. And if I connect to this via here, it should be ground. And it is. And then it goes straight across into this jumper link here, and if I measure that jumper link, I get 0 ohms right into the IC. There is no 75 ohm termination resistor here that I could find. That is internal to this IC. So what we're going to do is we're going to take a measurement from here, and then we're going to measure to the video signal coming out of the inductor, which is here. I'm going to probe right there. That's ground. I'm going to probe right there. 64.8 ohms. That's a little on the low side. So we know that's 64.8 on this inductor. So we're going to go on the other side and measure right here at the IC. 64.0. So that means the short is on this side and not this side. So we can pretty safely assume that this IC is defective. So what we're going to do, just to roll out the IC, we're going to remove it. And the way we're going to do that is I'm going to get this positioned, because I don't have a good way to, you know, mount everything up. So I want to get this positioned so the camera can see the best we can. Maybe, I don't know. So we're going to get that set up. So the next thing we have to do is grab our solder flux, and this stuff's getting old. I mean, look how amber it is now. This is supposed to be almost clear. So we have that as a problem, but that's not a big deal. So the way I remove these ICs is I like to put a little bit of flux on the pins themselves. That way it allows the solder to flow easier. And this is made in the error that it could be a toss-up between ROHS leaded solder or lead-free. This is right in that transitory period, so it could be either or. And lead-free solder is extremely difficult to reflow, especially without flux. So we're going to use a little bit of flux there. Then the next thing we're going to do is this little cheap little kit right here, which I got from Amazon. I mean, where everybody gets everything these days. So I'll have this little bit here, which is a little suction cup. What that allows me to do is pick up the chip, and this is the bulb. So let's grab the bulb, put it together, and so that will allow me, when I get the chip hot enough, to pull the chip off the board. And since I don't want to burn the table, I've got this old metal light fixture here just so I can get that done. The next thing I want to do is I want to grab this old El Cheapo heat gun, and we're gonna heat it up. Preferably not destroy the capacitors next to it. The best thing to do is, while you're doing this, is to watch the solder get solid, or it will start to reflow and it'll turn shiny. But before we do that, I like to preheat the board in the surrounding area first. So now that we're preheating the board, I can slowly draw closer to that IC, and I'm going to lean the heat away from these capacitors. I can change them anyways, but they're fairly solid capacitors. So we're going to go ahead and just reflow this chip and remove it out of the circuit. Flux is already starting to bubble and stinks like hell, of course. Also, I have the chip centered away from the metal so it doesn't absorb all the heat. We're getting close to reflow. Boom. Turn the gun off and just kind of slowly let it cool down. We want to reduce the amount of thermal stress to the board as best as you can. It'll never be perfect, but we don't need any excessive thermal shock than what there needs to be. Alright, so that has been removed. Now, just so you, in case you think that I'm trickery or anything like that, it's a TA0748 Revision B board. So this is the board, if you followed earlier in the video, that does not work. So we're done with that. We can go ahead and take our tool apart now and put it back into the enclosure. Close it. Move it out of the way. Alright, so the chip has been removed. At this point, it's pretty much now... The chip didn't get excessively hot from what I could tell. But now that the chip is removed, let's see what our reading is this time. I'm going to put the ground on the ground. Now, this is sitting on metal, so there's a possibility there could be a short. So we're going to take it there, and we're going to move it right here. Boom. 76 ohms. So there you go. Now, there must be a 75 ohm resistor here that I'm not seeing. But as you saw, with the chip in place, it was 64 ohms. With the chip removed, it's closer to 75 ohms. And that's exactly how it's supposed to read. So we have come to the conclusion, a pretty strong conclusion, that this IC right here, and it's still, this is why I hate flux. Oh, that was stupid. That's plastic. You know, I'm going to leave this blooper in the video because I think it's funny. That's plastic. Oh, yeah, yeah. I made my mark. Oh, well. So, we can come to the safe conclusion that this IC, if I can get it in there, is defective. This is a SAA 71298H. So, unfortunately, I do not have the parts yet. I'm going to have to wait for the parts to come in, and this video is getting excessively long anyways. So, that's metal. I didn't screw that up, at least. So, we're getting to the point to where this video is getting long enough. I have to wait on parts to come in so I can replace that chip. And you can see where it's left a little bit of flux residue. So it's not too bad. So I can clean all that up, add some fresh flux, and I can flow a new IC right in its place. And I didn't damage the capacitors. So controlled heat is always key. So the video's getting long. We're going to go ahead and end it right here. This will be part 1 of the IntelliStar repair series. I still have yet the thunderstorm card that I got to work on, which is actually, hold on, right here. This is the thunderstorm board, and this board, I kept the chip in here for safekeeping, but I have to resolder it back on, you know, in place of that, because that's the main firmware that boots the board. The problem was I had a good friend of mine had an issue with a power surge or something like that, and it interrupted the flash, which basically bricks the board. The board doesn't work anymore. So I sacrificed mine so I could fix his. He came up here and got it repaired, and pulled him out of the weeds, got his board working again, and just kind of left mine in a state of disrepair. So I got to take care of that too, and I will potentially put that in this video as well. I'm sure this board probably has a special bootloader mode to where you could reflash it in case there's like a recovery mode, but I don't know what that is. The weather channel would be the only people that know that, and we don't have access to that information, so I'm doing it the best way I know how, and that is to replace this chip, reflash it with my programmer. The TL866 does support this chip, so you can reflash this IC outside of the board. And when you're changing software versions, there was different versions of software that this board gets flashed with, so if you're bouncing back and forth all the time between the different versions, you're going to continually reflash this chip, which will wear it out in time. So just keep that in mind as well. Anyways, so that's it at this point. The next thing we got to do is we got to fix this. We got to fix the power supply, and we can start buttoning that thing up. You know what to do. Give me a thumbs up. Leave a comment if you have one. I've also started a Discord server that I'm going to start publishing, so you all can hop on my Discord and hang out and do whatever you want. And that link will be in the video description down below. It will also be on my Twitter feed if anybody wants to join the server. It's brand new at this point, at the time of making of this video, so there's not much on it. The channels haven't all been figured out yet, but we're getting there. So if y'all want to join, The link will be in the video description. In the meantime, thank you for watching,